As we promised earlier, we are going to teach you everything based on the official documentation, so that after this course or in every field that we are explaining, you will learn everything regarding it, so you could just handle the errors, because you know all based on the official documentation. So in here, if we go to this address man7.org, we could see the manual for implementing the IP protocol. If you look in here in the description, it says Linux implements the Internet Protocol version 4 described in these RFCs. We could see these things in the Linux terminal too. In here in the Kali Linux, if I type man IP.7 and hit enter, we could see the manual. We could see exactly the same thing that we are seeing in here. Actually you could see everything in the Kali Linux. The reason for everything that you click or that you do in the Kali, there is a specific file for that you could see why and how it is happening, because it's all open source. So in here, just for a better view, I'm browsing it using a browser. If you look, it says Linux implements the Internet Protocol version 4 in these RFCs. Now RFC 791. So if I go in here, let's see what these things are. So when this protocol, the IP protocol, was going to be created, as you see, it says this document specified the DoD or Department of Defense standard Internet Protocol. So the Internet Protocol was first defined in here, and this is the official documentation of how IP protocol should work. If you look again, this is it says the Internet Protocol is designed for use in interconnected systems of packet switched computer communication networks. What it means when we say packet switch is that every packet that is going to be sent should be separately treated, should be completely independent, and where it should know how it could get to the destination. Let me just show you a packet in here. We could just open the Wireshark or T-Shark as the CLI command tool. So in here, if I press Ctrl Shift and T, let me actually bring up the Wireshark. So I say Wireshark and ampersand to be executed in the background. What I'm going to show you is that you see a sample packet and see how a packet is actually formed. So in here, the active NIC that I have currently is ETH2. We could see it by going in the terminal and just type in here, type ifconfig, and you see ETH2 is the only available NIC that has an IPv4 address 192.168.1.7. So this is the Wireshark. I say start the capture using ETH2, and in here let me just create some packets by saying so just saying anything. Let's say ping google.com, hit enter, Ctrl C to delete, and in the Wireshark I just stop the capture. Now if you look, we have captured a lot of packets, exactly 21 packets. Now this is one of the packets that says from the source of 192.168.1.7 and to the destination of 192.168.1.1, which is a DNS packet. This is my router. So my router is acting as a DNS server. That's why my computer, my Kali Linux, is sending the DNS request to this router, even though these are not actually in the scope of this course. But I want to go to the packet in here. You see, this is the whole packet in the binary format or in hexadecimal. You could just right click in here and say as bits to see the real bits that are going to be sent. Now the data that in this example, again, I just want to prove a point. You don't need to know what these packets are or what the DNS is. If you want to know, of course, we have other courses out there. But in here, in general, my computer wants to send a DNS packet to get some information, in this case the IP address of the domain that we specified. So in here, these are the real data that my computer wants to send to the router. If you pay attention again, it says that I want the IPv4 address relating to the domain name of google.com so that I could ping it. But how does it know that where to send? Well, it knows it should add some headers, because we said the packet switch networks, the packet itself should contain some information so that it could get to the destination separately of other packets or routers. If a router is down or a hop is down in between, it could just go to other hops until it gets to the destination. So it must contain different information in itself. That's why other headers would be added to the main data. So the main data that computer wants to send is just in this layer that you see. So three different headers would be added to my data. One of them is the header related to a protocol in the transport layer. Well, in here, in the third layer, let's say in here, or the second layer, if we go from top to bottom, we have the TCP or UDP layer. The DNS works with UDP, so some header would be added. The main information in here are the source or destination port number. Then we get another header. We have another header, which is the IP header. Again, in the IP header, some information are added. The main information are the source and destination IP address. That's why a packet could get to the destination separately, because it has the source and destination IP address and the source and destination port number. Also, there are other flags in here for fragmentation, other things that I said is not for the scope of this course. Again, after all, another header would encapsulate all this information, which is the Ethernet header and has the physical addresses. But what I was gonna tell you is that how these headers are added, based on what documentation these headers are added to the main data. Well, based on the information in here that you see, the RFC 791, the implementation of IP protocol, or the IP protocol itself, is actually how the computer knows what information to add to the real data. We could just go through this to see exactly the different headers that are added. Again, if I go down in here, the gateway protocols. Okay, for example, a specification, it says a summary of the contents of the internet header. These headers are the exact things that would be added in the IP header. You see version, the length of the IP header, the type of service, the total length of the packet, the source IP address, the destination IP address, some header checksum for ensuring of the security of the packet, the time to leave the protocol, the next higher layer protocol, and other things. So based on this information in this documentation, the IP module would be implemented somehow that it would add some headers to the data. Now, what we are going to do in this manual, the IP7 that you see, this is how Linux implements the Internet Protocol. So the Linux would look at this information and implements the Internet Protocol. So if we want to send some information, we need to know how a packet is sent, and then decide how we are going to add different information to our real data.